I would not start Firecrawl by asking whether it has an impressive demo. I would start with the first side effect. What can it read, what can it write, what account or runtime does it touch, and what proof does it leave behind when the run is over? That is the practical Doramagic reading of this project. The manual gives a better spine than a launch post because it forces a slower question: where does Firecrawl actually enter a workflow? In this case, the first useful note is, SDK and tooling ecosystem. Firecrawl ships first-party SDKs in multiple languages. The second note is the boundary. The project is delivered as a managed cloud service and as a self-hostable Docker stack, and it exposes its capability through a Node.js API, an internal SmartScrape service, and a broad SDK ecosystem. I would keep that sentence visible during setup, because most first-run mistakes happen when you treat a tool surface, an SDK, an extension, or an agent loop as if they all had the same risk profile. My first-run test would be intentionally boring. I would create one disposable workspace, one reversible task, and one output I can inspect without trusting the agent or the UI. If the setup requires credentials, browser state, local files, or a running service, I would use test data first and keep the production account out of the first pass. The manual also points to the failure mode I would watch first: system architecture. The architecture separates a stateless HTTP API from a stateful job processing layer, with a dedicated internal service for AI-driven extraction. A clean demo can hide this. The project can appear to work while the real contract is still unclear: which command was run, which file changed, which remote call happened, or which source produced the answer. For verification, I would not accept a success message by itself. The SmartScrape subsystem, reachable via the smart_scrape_API_URL configuration variable, is invoked by the main scraper to extract structured data from a page using a prompt and a Zod-generated schema. In a technical creator workflow, the proof is the command, the trace, the changed file, the generated artifact, or the exact response shape. Anything less is just a story about a run. Here is the concrete first-run checklist I would use for Firecrawl. Step 1. Open the Doramagic manual and the upstream repository side by side. Step 2. Identify the smallest entry point, not the most impressive one. Step 3. Run one task where failure is cheap. Step 4. Save the log or output. Step 5. Decide whether the next run deserves more permissions. I would also cross-check the repository directly at https://github.com/firecrawl/firecrawl. The manual is the map, but the repository is where version drift, installation details, and real issue patterns show up. If those disagree, I trust the live upstream evidence before I trust a polished summary. My verdict is narrow. Firecrawl is worth exploring only after it passes one small, inspectable workflow. Do not turn it into infrastructure because the category sounds useful. Start with one scenario, keep the boundary tight, keep the evidence visible, and only expand after the first run is genuinely repeatable. For this video, the important thing is not the name Firecrawl. The important thing is the habit: manual first, source second, tiny run third, evidence before trust. That is how I would keep Firecrawl from becoming another tool that looked promising for an hour and then created a maintenance problem for the next month. See notes, read the project by its first side effect: SDK and tooling ecosystem. Firecrawl ships first-party SDKs in multiple languages. Decide what it can touch. The project is delivered as a managed cloud service and as a self-hostable Docker stack, and it exposes its capability through a Node.js API, and use the manual as the spine. The project is delivered as a managed cloud service and as a self-hostable Docker stack, and it exposes its capability through a Node.js API, and make the first run deliberately small. The project is delivered as a managed cloud service and as a self-hostable Docker stack, and it exposes its capability through a Node.js API, and watch the failure that looks like success. System architecture. The architecture separates a stateless HTTP API from a stateful job processing layer, with a dedicated internal service for Keep proof on screen. The Smart Scrape subsystem, reachable via the smart_scrape_API_URL configuration variable, is invoked by the main scraper to extract structured. Crosscheck upstream. I would keep the repository open while testing. https://github.com/firecrawl/firecrawl. Only expand after one useful pass. For Firecrawl, the decision is not whether the demo looks good. It is whether one narrow workflow produces inspectable, repeatable evidence.